Here we need ground collision, but before adding that, let's organize scene. I don't want to connect this way, right? So I'll just delete this and I will just copy this over here. One more node to input there. Cool, that's it. And let's just talk about what we learned till here. And so this is the geometry scale we have. After that, we are scattering some particles on it, and we have attribute as well. And this is converting that into a volume. After that, we are using this as a source. And here we are just using this object, source, and brain over here. And after that, we are calling everything over here. So let's just name this import dust, and here's the default object, which is this one. Yep. So if I zoom in and visualize this over here, I need ground collision, and for that I can quickly use this ground collision. And if I use merge over here, it has that left input affect right input, right? So I have to merge this first, and after that I can use this merge. So let's just reset the simulation. It's working. If I go outside and just cross check, yep, it's working. But for this kind of flat surface, we can even use simple approach. So here, if we select this, we have some max size and boundary conditions as well. So what max size and everything? Let me take a screenshot. So in old school Pyro solver, we have to define the boundary where we need to simulate. So in that boundary, we have option that we need to collide with this boundary. But with sparse solver, it's very smart. So wherever there is a source, it will start emitting without defining domain for this one. So here also we can, without defining this domain, we can mention that we need to close below y-axis. Yeah, so as you can see, it's very fast, and if I reset the simulation, it will take lesser time. And one more tip I wanted to give you. So as you can see, this is really close to the grid, right? So if it's not close to the grid, right, so it is somewhere here in the axis. Will it still simulate? The answer is no. It's not simulating. So why? Do we need to define domain for this as well? Nope. So if I select this, I have one option, enlarge fields to content sources. So as you can see, it's emitting something over here. Now if I reset the simulation over here, it will simulate that. Sometimes it's not close to the grid, it won't simulate if you don't turn on this option. Well, and now I want to disable this disturbance. Yep, let's just check this now. And we can delete this transform. So now what we need over here is inheritance of the character. An object in motion stays in motion. So for that, let's talk about velocity. Yep, so I have this sphere moving around, right, in 3 axes. So velocity is vector value. So it has 3 values, x, y, z. I want to calculate speed, which is single value, meaning it's a float. So I need magnitude of vectors. On paper, I have to calculate vector speed is equal to square root of axis x, y, z. So for now, let's take 1, 1, 1 axis. It will look something like this. So if we combine all of them and we find a square root value of that, this is the actual speed if we use this 1, 1, 1. So that's maths behind it. So who needs smart calculator? We can easily use length function. and get that speed value, and even we can link that value to any color we want. So here let's just add some color as well. Most trickiest part in like simulation is when it stop moving, it should stop emitting as well, right? So where we can use this maths. So let's implement this in Houdini. So I need velocity, so let's calculate velocity of character. We can just put trail over here, compute velocity, and if I middle click over here, it's not there, so I need to attribute transfer that. So it's there, right? So let's just visualize how it looks. So if I go over here, it's not there, right? So if I want to view that velocity, I can just go over here and click V, and let me just check. Now I have that option. Yep, it's working. And here also, this is how velocity looks like. And if there is anything wrong, we can just cross check over here. We can see something in viewport, it's not actually there. We need to reset the viewport. It's removed. Cool. Let's just reduce this. I want to set some limit over here, so I'll just transfer in this distance threshold only. And now save this. Cool, we have it over here as well. But if I select this, I don't have it over here anymore. So pyro source doesn't transfer that velocity. But if I use V and even select this velocity also, it won't take that value. So it's better we use this attribute transfer again to get that velocity in here as well. Set the radius to 1. Yep, it is there now. So simply we can write V over here and it will add that velocity field. If I middle click, you can see it's velocity field, right? So but if I go like high resolution, right? So if I middle click, just check how much voxel it's consuming over here. And at the moment it's 9 MB. So if I remove this velocity only, you can see velocity is taking 6 MB, and this is just really small source. Just think about the what if you are working with large scale, right? So in that case it won't be helpful. So it's always better to use this separately. And here we will have fixed voxel. Maybe we can just use 0.5. That's the value. Let's just check how 0.5 looks. Yep, for velocity it's fine. We don't need that extreme resolution in here. And now we can merge this. Yep, it's working well. At the moment it's too high resolution. Let's just reduce that. Yep, and one more thing, as you can see it's stopped over here, right? So I don't want to emit smoke over here. So for that, let's just make some room, as we will add some extra nodes over here. So for that I was talking about the length, right? So let's use that. So we will use point triangle. Right, so here if I middle click, I have that density attribute. So let's take advantage of that. We can manipulate density attribute over here. If I just type density 0, yep, it's working. So what I need over here is I want to link this to velocity. So let's type at speed equals at v. So at the moment this is vector, so we need to check the value of this, what's happening over here. So we can just go to geometry spreadsheet, and here I can just check the speed, right? So we are getting some speed. So this is vector value first, so we need to convert this into a magnitude, right? So let's type length of velocity. Yep, so this will give me some value. And if I go over here, yep, it's working. Let me visualize this. Is it working? So we are getting very low value over here. This is quite high value, but still, yeah. On this frame, as you can see, it's going above 1.4, right? Let's just visualize this over here. So to visualize this, we can just use CD, and let's just set that value at speed. It's 0, 0. Yeah. So as you can see, if it's moving, it's okay. I need some value here as well, so it's easy to visualize this. So when it's yellow, it will emit, otherwise it won't emit. So that's what it's doing. And here, as you can see, some of those values are going above 1, so we need to feed that value. So we can just simply type feed 0, 1. So it will just stay between that value, it won't cross that over here. Can you see? Cool. So I think now it's time to multiply that with density. So whatever above value we are getting, we need to multiply that with speed. Cool. So now if I check, yep, that's exactly what we want. So now let's just check. So after adding velocity also, it's not working. So we have added velocity over here. So as you can see, it's still density, right? So we need to change the name of this V over here. And if I middle click, now we have that velocity. Let's reset the simulation. Still it won't read that by default. Now let's dive inside. We have to make sure that we need to read that velocity over here. So if I type V and V and it's a vector, will it work? Still it won't work. Pyrosolver doesn't understand V. So what it understands is well. So we have to make sure we properly type these things over here. And now if I check this, reset this, awesome, that's working. So an object in motion stays in motion. Cool. So we have some operations as well. We can subtract, multiply. So you can always explore these things, what it's doing. You can just use extreme number over here as well. Right, so these things are useful in some cases, but in this case we can use add only because we want to add velocity per frame. Yeah, so I will recommend to test all this operation for better understanding, but for now that's fine. Let's just go with one scale and let's make a flip book. Let's play this. Yep, this looks cool, and we will add some micro solvers next.